Imagine a world where people believed the Earth was the center of the universe, where the stars and planets revolved around us, and where the idea of using tools to enhance our senses was considered heretical. This was the world in which Johannes Kepler lived. His journey to unravel the mysteries of the cosmos was a blend of divine inspiration, scientific curiosity, and sheer persistence. This is the story of how Kepler, a man with a passion for mathematics and a deep faith in God, transformed our understanding of the solar system and paved the way for modern physics. In the summer of 1595, Johannes Kepler, a young mathematician and teacher, was struggling with a problem that had puzzled him for months. He was trying to understand why there were exactly 6 planets, and why they were spaced the way they were. The idea that the Earth was not the center of the universe, as proposed by Nicolaus Copernicus, was still a radical and controversial notion. Kepler, who had converted from a career in theology to astronomy, was deeply committed to proving Copernicus right. One day, while teaching his class about the conjunctions of Saturn and Jupiter, Kepler had a sudden epiphany. He was drawing triangles within a circle to show how the conjunctions of these planets occurred successively 8 zodiacal signs later. As he inscribed one triangle after another, he noticed that the points where the lines of the triangles crossed outlined a smaller circle within the larger one. This inner circle, he realized, could represent Jupiter, while the outer circle represented Saturn. This simple geometric pattern was the first clue that would lead him to a groundbreaking discovery. Kepler's mind raced with excitement. He recalled a remarkable coincidence. In geometry, there were 5 types of regular polyhedrons, and there were also 5 planets besides the Earth. This seemed too much of a coincidence to ignore. Kepler wondered why he should confine himself to 2-dimensional figures when the orbits of the planets were 3-dimensional. He decided to explore the idea of fitting the planets into a series of nested polyhedrons. The idea struck him like a bolt of lightning. He imagined the Earth's orbit as the central circle. Around it, he circumscribed a dodecahedron, and the circle containing this dodecahedron would be the orbit of Mars. Next, he circumscribed a tetrahedron around Mars, and the circle containing this tetrahedron would be the orbit of Jupiter. He continued this pattern, circumscribing a cube around Jupiter to get Saturn's orbit, and inscribing an icosahedron within the Earth's orbit to get Venus's orbit. Finally, he inscribed an octahedron within Venus's orbit to get Mercury's orbit. Kepler was elated. He had found a geometric pattern that seemed to explain the number and spacing of the planets. He wrote down his discovery in a book called Mysterium Cosmographicum, which he published in 1596. To him, this was not just a scientific achievement, it was a divine revelation. He believed that God had designed the universe with a perfect mathematical order, and he was humbled to have uncovered a small part of this divine plan. However, Kepler's discovery was not without its flaws. When he compared his geometric model to the actual orbits of the planets, he found that there were discrepancies. The orbits did not fit perfectly, and there were some errors, especially with Mercury. But despite these imperfections, Kepler's model was a significant step forward in understanding the solar system. It was the first outspoken defense of the Copernican system after Copernicus himself, and it laid the groundwork for future discoveries. Kepler's passion for astronomy was not just scientific, it was deeply spiritual. He saw the sun as a symbol of God the Father, the fixed stars as representations of the sun, and the sun's force as the Holy Ghost. This mystical view of the universe influenced his scientific work. He believed that the sun was not just a source of light, but also a source of force that governed the movements of the planets. This was a radical idea at the time, as most medieval astronomers believed that each planet had its own moving spirit, or celestial intelligence that guided it through the heavens. Kepler's initial idea was that the sun's force weakened as it moved away from the planets, much like a magnet's force weakens with distance. He proposed that the sun's force was the driving force behind the planet's movements, and this force decreased as the distance increased. This was a significant departure from the prevailing theories of the time, which were often rooted in mysticism and animism. Kepler's work did not stop there. He continued to refine his ideas and collect data. He was greatly influenced by the observations of Tycho Brahe, a Danish astronomer who had compiled the most accurate and extensive data on the positions of the planets. Without Brahe's data, Kepler's discoveries would not have been possible. Using this data, Kepler formulated his 3 laws of planetary motion, which are still fundamental to our understanding of the solar system today. Kepler's first law, known as the law of ellipses, states that the orbit of a planet is an ellipse with the Sun at one of the 2 foci. This was a revolutionary idea because it contradicted the long-held belief that the orbits of the planets were perfect circles. Kepler's second law, the law of equal areas, states that a line segment joining a planet and the Sun sweeps out equal areas during equal intervals of time. This law explains why planets move faster when they are closer to the Sun and slower when they are farther away. Kepler's third law, the harmonic law, states that the square of the orbital period of a planet is directly proportional to the cube of the semi-major axis of its orbit. This law provides a mathematical relationship between the distance of a planet from the Sun and its orbital period. Kepler's laws were not just theoretical, they had practical applications. They allowed astronomers to predict the positions of the planets with greater accuracy than ever before. Kepler's work laid the foundation for the development of modern physics, and his ideas influenced later scientists like Isaac Newton, who formulated the law of universal gravitation. While Kepler's geometric model of the solar system was not entirely accurate, it was a significant step forward in the history of astronomy. It showed that the universe could be understood through mathematical and physical principles, rather than mysticism and superstition. Kepler's work was a bridge between the medieval view of the cosmos and the modern scientific understanding of the universe. The invention of the telescope was another critical advancement in the history of astronomy. Unlike Kepler's geometric model, the telescope was not the result of a single brilliant insight. It was the product of chance and practical ingenuity. The first eyeglasses were likely invented by chance, perhaps by a glassmaker who discovered that a curved piece of glass could help him see better. These early eyeglasses were used to correct presbyopia, a common condition that affects vision in older adults. The first recorded use of eyeglasses dates back to the early 14th century, and by the mid-14th century, they were common enough that laws were passed to regulate their production. However, the invention of the telescope was a different story. The idea of using lenses to magnify distant objects was not a popular one. Many people believed that the human eye was perfect, and that any attempt to enhance it was a form of trickery or deception. The invention of the telescope is often attributed to Hans Lippershey, a Dutch spectacle maker who lived in the early 17th century. According to legend, Lippershey's children were playing with his lenses one day and noticed that when they held 2 lenses together, distant objects appeared much closer. Lippershey saw the potential of this discovery and began making telescopes. He applied for a patent, but the Dutch government denied his request, believing that the invention was already known to others. Despite the controversy, the telescope quickly spread across Europe. By 1609, telescopes were being sold in Paris and London, and they were used for both military and scientific purposes. The telescope allowed astronomers to see the surface of the moon, the moons of Jupiter, and the phases of Venus, all of which provided strong evidence for the Copernican system. Galileo Galilei, one of the most famous scientists of the time, was one of the first to use the telescope for astronomical observations. His discoveries, including the moons of Jupiter and the phases of Venus, provided crucial support for the Copernican theory. Galileo's work, combined with Kepler's laws, helped to solidify the heliocentric model of the solar system and laid the groundwork for the scientific revolution. The telescope and Kepler's laws were not just scientific achievements. They were also cultural and philosophical milestones. They challenged the medieval view of the universe and opened up new possibilities for understanding the natural world. The telescope showed that the universe was vast and complex, and that there was much more to discover. Kepler's laws demonstrated that the movements of the planets could be explained through mathematical and physical principles, and that the universe was governed by natural laws rather than supernatural forces. The story of Kepler and the invention of the telescope is a testament to the power of human curiosity and the importance of scientific inquiry. It shows that sometimes the greatest discoveries come from the most unexpected places, and that the pursuit of knowledge can lead to profound and far-reaching insights. Kepler's work and the invention of the telescope were not just about understanding the stars. They were about understanding ourselves and our place in the universe. They remind us that the more we learn, the more we realize how much there is still to discover.